So on the agenda for today, we're going to provide a brief background on child welfare algorithms. What does that mean? What does that entail? Including a history of child welfare services algorithms. We're then going to explain the differences between two algorithms in particular, which are CANS and 7EI, and the design guidelines that we've learned from that case study. We'll then present our NLP solution and discuss future work, and then also welcome questions in the Q&A period. So the main question that we want to explore here is, how can we build an algorithm for child welfare services that works for everyone? We really think that through our research, what we've learned is that algorithms should be used to augment decision-making processes, but not to supplant them. So algorithm decision-making should support human discretionary work, but it shouldn't totally replace it. Decision-making algorithms that are solely quantitative, so that only use numerical data that are used in child welfare services, can produce biased outcomes, especially with respect to racialized and low-income families. So we've seen a host of issues here, ranging from surveillance to biased outcomes for certain demographics, and that's really the problem space that we're operating in. Especially in high-stakes contexts like child welfare services, the need for caseworkers to not rely solely on algorithms is super important. So we're hoping to demonstrate how a reliance on algorithms that are solely data-driven removes context and hinders the reunification process, which disproportionately is to the detriment of racialized and low-income children. We'll also discuss the misalignment between policy goals of reunifying families, regardless of race or income, in extremely high stakes situations. So of course, in a child welfare situation, taking a child out of their home is a very high stakes decision. And so we want to make the argument that in order to reduce bias, there needs to be a key consideration of context for both technologists and for policymakers. So again, the question central to our research is, how can we build an algorithm for child welfare services that welcomes everyone?
Okay, so to start, I'll go over how the algorithms came to be. Going back a little bit, in 1993, the ACLU brought forward a lawsuit to the state of Wisconsin for failing to provide adequate child welfare services. A settlement was reached, and the state was mandated to comply with 13 requirements to improve child welfare services. And while the state was able to make good on the majority of the requirements, placement stability was one of the anomalies and was an area the state needed to comply with. So research shows that the best thing for a child is to have stability. What we don't want is for children to be moving through homes or centers into foster care system for years. So placement stability is a technical term used to refer to the likelihood that a permanency plan will remain effective and in the best interests of the child. To alleviate the burden, the state implemented algorithms at several stages of a child welfare case to see if they could algorithmically predict things related to child welfare cases, including predicting the best case scenario to increase child placement stability in child welfare. So overall, to aid in child welfare processes, the state decided to implement algorithms at various points of the child welfare process.
So the algorithms that are used specifically in child welfare agencies, and here Erina and I are building on Devansh's research that conducted an extensive ethnography at the same agency that we partner with, where he conducted interviews with caseworkers and observing caseworkers' meetings to understand their daily practices and their perceptions towards decision-making algorithm used in child welfare services. So that's kind of how the algorithms were informed and the basis with which we conducted this study. So as I mentioned before, there are many different algorithms that go into child welfare services, but for the purposes of this presentation, we just want to focus on two. And we really want to highlight how the two algorithms optimize for different factors, and hopefully, as you'll come to see, which ones lead to better outcomes holistically for children. I'm just going to cover the algorithms, and Erina will cover the next algorithm at a high level. And if we want to go into more technical context, we're happy to take questions in the Q&A period. So CANS is the first one that we want to discuss. It's child and adolescent needs and strengths. which is mandated by the state and is conducted every 6 months. So caseworker will interview the foster parents and ask them about any changes in the child's behaviors, any risks and needs. This information is fed into the CANS algorithm, and then it produces recommendations, which include the level of foster care, so where the child should be, the compensation that should be therefore provided to the foster parents, and the level of foster care. So what we're seeing is that the level of foster care is often ignored in subsequent assessments because, as Erina mentioned, placement stability is really important. And so the only reason that they would want to disrupt the placement is if things are getting progressively worse. But in general, what CANS is used for is to assess the compensation based on the mental health needs for the child. So CANS will recommend services such as individual therapy and will determine the level of compensation. But essentially in this dynamic, the higher the needs of the child, the more compensation foster parents are provided. But this practice causes problems because, firstly, CANS paints an isolated view of the child, and it doesn't go into the understanding of the traumatic triggers in their ecosystem. It doesn't assess their situation holistically. The second reason is because higher mental health needs mean higher compensation for the family, but because CANS lower the compensation for foster parents when the child is doing well, it therefore changes the dynamic with respect to incentives, which has not been proven to be a good thing for the child. So this is a testimonial from Devansh's paper in his interview with Child Welfare Services, and it says, "It is the complete opposite of what we want it to do. Foster parents help minimize the behaviors and offer support so that kids can develop good coping skills. They help address the mental health needs and help kids stabilize by taking them to therapy and all their activity. But then they're punished because the kids' needs go down and so does the rate." This is pretty indicative of what caseworkers feel across the board, essentially that CANS lacks context and focuses on current behaviors, not trauma or triggers. And it also makes the foster parents feel like they're being punished in terms of compensation when a child does well. As I mentioned, if a child does well, the compensation goes down. So overall, CANS wasn't working great.
So in contrast to CANS, we have 7EI. 7EI is a locally developed algorithm which centers in trauma-informed care. Unlike CANS, it's not legally mandated by the state, and workers note that it's useful because it allows room for discussion and provides a comprehensive view of the child and their ecosystem. So the algorithm is designed to be used in a team setting so that expertise from the entire team can be leveraged and decisions are made through consensus decisions. So what happens in 7EI? The team discusses and scores the child's and caregiver's wellness on 7 domains as depicted in the figure here, and collectively thinks through solutions. 7EI assessments are individually focused. However, unlike CANS, the results are trauma-focused and also guide family interventions, highlighting areas of children functioning upon which the caregivers and professionals should focus their attention. So by basing child welfare decisions informed by trauma-informed care, 7EI algorithm has been proven to improve child outcomes such as placement stability and permanence. It's a prescriptive tool that assesses a situation using a prescribed framework, but it's still human. So caseworkers who are taking these measurements, and it's these caseworkers who are then making decisions. So here is a quote from Devansh's paper on caseworker perceptions towards 7EI that we want to highlight. "We have tried the cookie cutter approach in the past, assigning everyone to parenting classes, therapy, and other family support services. It failed, and it is horrible to do to a family. So with 7EI, we focus on addressing core issues, whether it's the parent's self-esteem, their own abandonment issues, or child's emotional regulation that will really help this family." Clearly, the addition of context works well in 7EI, but it's also not enough, which will bring us to the introduction of our next section.
So what we learned from these 2 case studies, as well as from an assessment of other algorithms that are used in child welfare services, is that there are design guidelines that can be suggested based on the audit of these and other algorithms. So first is that algorithms should be multidimensional and should use many metrics. So one of the key differences between CANS and 7EI is the number of inputs that are going in. So in a CAN situation, we're not assessing as many metrics as in a 7EI situation, and clearly the addition of more multi-metrics and multidimensional algorithms is better for the child. The second guideline is that algorithms should be used as suggestions, but not as mandated outcomes. So again, with 7EI, it's still a caseworker who's making the decision for the child's placement or for the plan at the end of the day. It's not an algorithm that's mandating something, because again, algorithms have their limits with respect to providing context and being able to assess context. You really do need, especially in high stakes context-rich situations, an expert such as a caseworker or a social worker to be able to holistically assess the environment for the child. Algorithms should also account for uncertainty. So there is a high degree of uncertainty. Things change very quickly, especially in the public sector, especially in high stakes situations, and algorithms need to be able to account for that. They should also consult with key stakeholders. So having an algorithm be part of an ecosystem where families, caseworkers, policymakers, children are working together for the betterment of the child is a much better situation in terms of the benefits for the kid and providing context versus having the algorithm be divorced from the ecosystem of care for the child. And finally, we should always account for resource constraints. Unfortunately, there are resource constraints that we have to deal with. So it's not always possible to have a caseworker thinking through that or providing that many resources for a single child. So we want to make sure that the algorithm and the use of the algorithm is mindful of that. So back to our initial question, how do we build better algorithms that will work for everyone? Our method was to use topic modeling, and Erina will expand on this, but I just wanted to provide a brief introduction to what topic modeling is. Just to give an overview for those who are not familiar, it's a group of statistical methods that are used to for latent topics that occur in a collection of documents relying on word distribution in each document. So it is a natural language processing technique that's unsupervised, and it allows us to go through many case notes quickly and then understand the key terms, the key trends present in those case notes. So for our purposes, we had about a year worth of case notes on children in the welfare system. And using this process, we were able to see what are the themes that emerge the most frequently, how are those themes related to one another, how are they related to outcomes. And I'll pass it to Erina to explain more.
So we adopted the approach taken by Antoniak et al.'s paper, Narrative Paths and Negotiations of Power in Birth Stories, that was published in 2019. The methods covered three aspects: data, topic modeling, and analysis. We took the following steps for our research. So first, our data set was cleaned to remove punctuation and stop words, merged in chronological order for each family, and anonymized to protect the privacy of the authors and their personal information. Since we were primarily interested in text, numerical data fields were ignored. Second, we applied topic modeling methods using Mallett's implementation of LDA, latent Dirichlet allocation. LDA is one of the most popular and efficient topic models. And then finally, we adopted a combined manual and computational approach for our analysis. We manually assigned labels to the topic model solutions and leveraged the expertise of frontline caseworkers to validate our labels and to get some feedback. We also manually predefined a list containing the main personas that appear frequently in the case notes and replaced similar references in text with the corresponding keywords from the persona list to understand power dynamics between frequently occurring characters that appear in the case notes. In addition, we analyzed sentiment, observed how topics change over time depending on family.
So essentially with topic modeling and with the addition of qualitative data into this algorithm, we're looking for words and themes that are most likely to occur. There is some math behind it, which I won't go into for the purposes of this talk today, but in general, that's what an NLP is doing. It's looking for patterns within the text data. So I just want to highlight some of our findings. And for the sake of time, we won't dive into all 17 topics that we found, but the couple that give us a lot of insight is first the topic 1, which focuses on conflicts during visitation. So the way that topic modeling works is the first topic will be the most prevalent, and as you go down the list, that's the one that's coming up the least often. So topic 1 is the most frequently seen. And so we're seeing that conflicts during visitations is one of the things that come up very frequently. So this is important because it tells us that caseworkers, in addition to providing support, also resolve and manage conflicts between different parties within the ecosystem, requiring soft skills and, of course, social work training that they are professionally trained to do. Topic 3 addressed the medical aspects that are present in a lot of cases. Topic 12 was court proceedings. So the legal aspect, again, the child welfare system and the legal system interact very closely with one another. So that was expected. But topic 14 shows an important finding. So it's about the way that caseworkers staff assess how safe family homes and how safe placements are. And that is an exercise that is inherently subjective in nature and depends on caseworker judgment. So it's therefore open to caseworker bias. So what was interesting here is that this topic is 14th out of 17 topics. That indicates to us that this topic appears less prominently than the other ones in the case notes. So caseworker assessments play a vital role in algorithms such as CANS, but the low importance of this topic within our topic modeling suggests that the assessment of scoring is only one of the tasks of the caseworker. And so it should be treated as such, again, showing that holistic nature of caseworkers' job and the holistic nature of what it means to adequately assess a child's situation is very important, as seen by the difference between the first, so the most prevalent topic, and the 14th, the least prevalent topic, or the 14th out of 17th in terms of prevalence.
So our study revealed really interesting insights. We found that incorporating a participatory study design complements and validates topic modeling outputs, illuminating the benefits of a mixed methods approach when using machine learning. Our study did have a few limitations. We conducted topic modeling on a little over a year's worth of case notes for one child welfare agency in Wisconsin. Different states and different child welfare agencies may face different issues and power dynamics within their agency. However, despite the study's limitations, our analysis has shown that topic modeling may be applied to ethnographic case notes in the child welfare system to reveal a wide breadth of information. And our next step will be to examine whether topic modeling outputs can predict child outcomes, i.e. discharge status, within the agency.
So in summary, what we learn and what we hope to show is that topic modeling is a really powerful tool to discover themes in child welfare narratives. So a context-rich environment, lots of text data, topic modeling, or other NLP methods are a powerful way to comb through that amount of data and glean the important insights, and then of course apply them to the situation. So in our case, child welfare services. Another key finding is that participatory design complements topic modeling and makes for better results. So participatory design is the inclusion of key stakeholders. We mentioned before, caseworkers, foster parents, children, technologists, policymakers need to work together in an ecosystem in order to advance outcomes that are going to be beneficial for the child and for policymakers in general. Our last finding was that text does help to reveal power dynamics. So it helps to reveal what caseworkers do on a daily basis. And when we combine that with caseworker interviews or the caseworker ethnography that we mentioned before, we're able to create some really interesting findings, which will hopefully make child welfare services better.
So as mentioned previously, we are now examining whether topic modeling outputs can help predict child outcomes within the agency. So building on our topic model solution, we are applying the identified topics onto discharge case notes to see if they can determine outcomes for cases.
And we hope that this work will also help to inform legal or policy frameworks that are still needed to govern public sector algorithms. So when we know what works and what doesn't work, we're hoping that this will eventually help to inform policy guidelines and the regulation of algorithms that are being deployed in high stakes environments dealing with vulnerable communities.